Hi guys, in today's video I want to talk about Swarm Resiliency. So Swarm is an orchestrator for Docker, and we'll talk about how you can bring down a node, or if a node goes down, how Swarm will reschedule tasks across the available nodes. So an overview of what a Docker Enterprise Edition complete deployment looks like. So on your screen here, what you can see is we have the Universal Control Plane Manager nodes, so UCP, 3 of them for high availability, and then you typically have 3 Docker Trusted Registry nodes, so 3 DTRs also for high availability, and they would typically talk to or store the images on a shared storage that could be NFS on-prem, or it could be something like an S3 in AWS in the cloud. And then you'd have your worker nodes. That's where all the containers, your applications will reside. And in front of all these, you can put different load balancers. So that's typically what a deployment for high availability in Docker Enterprise Edition looks like. Now, what I'm going to do is I'm going to go over to my demo environment. And in my demo environment, I have 7 nodes. I have 1 UCP, so 1 manager, and 1 DTR. So this is not a high available cluster, but for demo purposes, it's good enough. And then I have 5 worker nodes. I got Linux 1, Linux 2, Linux 3, and Windows 1 and Windows 2. So that's the setup I have today. And what I'll do later is I'm going to stop Linux 3 and see how Swarm is going to reschedule the load. So now going over to the UI for Docker Enterprise Edition. Again, you can see the nodes here. So the same nodes that we saw from the AWS console. Now what I'm going to do is I'm going to create an application and deploy that. So I'll go over to stacks. I'm going to create a new stack. Dockercoins is the name of the application. And I'm going to select Swarm Services. And I'm going to copy my application here. I'm going to paste it over here. So this is a Docker Compose YAML file. And it has 5 microservices that work together for this application to work. And I'll talk about these briefly. So we have a random number generator, we have a hasher, we have a web UI, Redis backend, and worker. So every one of those services has a replica of 1, except for the worker has 3 replicas. And what we're going to do is we're going to kill a node that has one of those replicas and watch Swarm reallocate that container to a working node. So a brief overview of the application of what it does. Let me bring this over here. So Docker coins is just a mining cryptocurrency that we just made up, this Docker coins app. And what we're doing is we have a random number generator. Let me make this a bit bigger. We have a random number generator here. It generates random numbers, as you'd expect. Then we have a worker node that requests random bytes from the random number generator. Then it gets those random bytes, pushes it into a hasher service, and then based on that hash, if it starts with 0, we continue. We find it stores it into Redis, and then the web UI function or service grabs that from Redis. So let's go back, deploy the application. So I'm creating now the stack from that Docker Compose file, and I'm doing this through the GUI. You can equally do the same thing through the CLI. It works the same. So it really depends on your preference of how you'd like to work with your applications. So now that's done, we can see that we have a Swarm service called Docker Coins It has 5 services in there, and there's a network that links these services together. So now what we can do is we can inspect these services quickly just to see that they're all up and running. And as you can see, we have our Redis, we got our web UI, the random number generator, the hasher, and 3 replicas of the worker. So if we go back, I want to show you the containers so you can see where they're actually scheduled on the different nodes. So in this case, if we just filter here or sort by name, the hasher is on Linux 1, random number generator is on node Linux 1, the one worker is on Linux 1, Redis is on Linux 2, web UI on Linux 2, the second worker is on Linux 2, and the third is on Linux 3. So what I'm going to do is I'm going to stop the Linux 3 instance, that node, and we'll watch what happens to the application. But before that, let's take a look and see what the application is actually doing. So I'm going to go into the link, and on port 8000, that's where the web UI is running on. And as you can see here, it's running fine. We are collecting or mining dockercoins, and you can see the speed at which we're mining the dockercoins. So it's around 12 hashes per second here at the top. It varies depending on, you know, the random number generator, and if you see zeros. So but typically we're reaching up at the level of 12. This is important to note because when I kill the node Linux 3, one of the workers was going to go down, so obviously we're going to mine less coins. So you're going to see this function go down a little bit until the swarm scheduler schedules that worker onto a running node, and we'll come back. All right, so let's go over to the AWS console, and let's kill Linux 3, or let's just stop it. So I'm going to stop this instance. Yes, stop the instance. Let's see here, and you can see it's coming down a little bit. But let's go over to the nodes first. So let's exit here. You can see it turned from green to yellow, the dashboard. So if we go down to the nodes, you can see Linux 3 is now red. It's down. All right. So if we go over here, you can see it actually died here. The number of workers went down to 2, and then it came back up. So it was pretty quick, but it's good that we're able to capture it here through the application. But now, if we go back and look at our stack, inspect the resources, inspect the services first, we're still up at 3 replicas, so that's great. Let's go back and look at the actual containers. And here you go. You can see that worker 1 got rescheduled to Linux 1. So now we have worker 1 running here, worker 3, and worker 2. And now this is old. So looking at it in a different way, let's go over here. Let's do a docker node ls, just to show you how you can do the same thing from the CLI. You can see here Linux 3 is now down. Now let's do a docker stack ls. You see dockercoins, so let's do a docker stack ds dockercoins. And here you can see that the worker 1 that was running on Linux 3 is now shut down. And that was all about 4 minutes ago. We shut it down 2 minutes ago. And this is the new instance of the worker node here, running on Linux 1 now. And this was about a minute ago. So you can see that worker and worker and worker and worker. So worker 1 is the one that died on Linux 3, and it got rescheduled here, worker 1 on Linux 1. So now we still have 3 replicas of the worker service now rescheduled. So obviously, if you have more than those 3 nodes, what the schedule will try to do is reschedule this worker.1 on a separate Linux, maybe 4 if you have one, instead of rescheduling on Linux 1 where you have 2 services running on the same node. But this is what a declarative model looks like in terms of Swarm knowing that it needs 3 services to run the application. It will reschedule that container to a running node. Once again, we go back here. You can see the little blip right around here, and then we're back in business. So hopefully this helps to show how Swarm is resilient to node failures. And you can see our node has been stopped here. So once again, hopefully this has been helpful, and thanks for watching.